All right, guys, welcome back to another week of remote learning and science class. So I hope you guys are doing well, and let's just jump right in. We're going to talk about balancing equations this week. So balancing equations is something that I don't want you to get super stressed out about, because I know that when I took chemistry both in high school and in college, balancing equations was one of those things that it just takes a lot of practice. It takes time and patience with yourself. But some of you guys, this might come easier than others. So I will try to make it as painless as possible. And I found some cool tools that can help you out along the way. So follow along if you would. I'm going to start posting notes that go along with these videos. So that way, those of you that like to take notes or like to have something to kind of reference back to make sure that you're getting the main points out of the video, you can do that as well. So anyways, balancing chemical equations kind of works like this. Let's say that I want to build a bike. I don't, because I'm not handy. I cannot build a bike. Not talented in any remote way on how to do that. But if I was talented, some things that you would need tires, you would need handlebars, you would need pedals, and a frame. Now, would I be okay if I just said I need one? I just wrote a list, and let's say I've never seen a bike before in my entire life. Then if I just have one of each of those things, I'm going to get a really weird looking bike. In fact, it's not even going to be a bicycle at all, because it only has one tire. That would be one of those, I don't know, those fancy things that, like, you know, you always see in like the Victorian era. Somebody comment with what that is. I don't remember, and I'm just too tired to look it up at the moment. So if you can find that, find that online and let me know. Maybe I'll give you a prize or something. Anyways, so all of those go together to make a bicycle. But the thing is, you have to know how much of each thing goes in. So you need 2 tires, you need, like, I don't know if the whole thing counts as the handlebar, but like 2 handlebars, some pedals, in one frame. So it's all has to be balanced. So that's what we're doing when we're talking about chemical equations, is we're talking about the amounts of what we're doing, right? All of that matters. Same thing if you were doing a recipe, right? If you are making a, pizza or souffle or something like that, it matters how much you put in there. It matters what kinds of ingredients. If you mess up the proportions, then you're going to get a different thing altogether. So the guiding force behind why this matters is the law of conservation of matter. So I'm going to highlight it. Bam. The law of conservation of matter says that matter is neither created nor destroyed, only changed in form. So that means that when you are looking at chemical equations, you need to make sure that all of those atoms are counted for and that they're equal on both sides of the arrow. So let me pause here and I'll show you what I'm talking about. Okay, so here is an equation, and we have our reactants on the left side of the arrow and then our products on the right side of the arrow. So let's go ahead and balance this guy out. And these are the 3 steps that you can use to balance it out. So first thing we're going to do is we're going to count the number and the type of atom in the equation on each side. So on the left side, on our reactant side, we have hydrogen. We also have hydrogen over here. And then we have oxygen and oxygen over here. So what we need to do is we need to count up how many of each atom we have. And so this is where that skill of being able to understand how molecules are put together and what these numbers here mean. So keep in mind, I want to make sure that you understand this definition here. So this number, this number, this number, you cannot change those. Those are called subscripts. So let me write that in the corner for you, subscript. The subscript is what tells you how many atoms are in each molecule. We cannot change the type of molecule that we are putting in and getting out. That would fundamentally change the entire thing. So you got to be really careful. You cannot change that. So again, we're just counting up. So we have 2 hydrogens here. We got 2 hydrogens here. Hydrogen's balanced. That's good. Sweet. Now let's look at oxygen. I have 2 oxygens on the left and I only have 1 on the right side. So we're going to need to do something here to make this balanced, because according to the law of conservation of matter, we need both sides to have equal amounts of each atom. So now we have to balance those atoms out. So let's start by just going one more up. I'm going to add a 2 in front of our water molecule, H2O, And that means I'm going to have to erase here. So I would always recommend doing these in pencil, or at least leaving a lot of space for you to jot down notes, because it does change as you add these numbers. We call these numbers right here, this is your coefficient. The coefficient is the number that goes in front of the molecule, and that is what you're changing for each one. So here now we have 4 hydrogen, and we have, because 2 times 2. So when you see the subscript, you're gonna have to multiply. So 2 times 2 is 4, put a 4 down for hydrogen. 2 times, we assume that's a 1, so that's gonna be 2. Now our oxygen is good, but guess what? We gotta change our hydrogen. Now this is an easy enough fix. All you have to do here, let's just move this guy up to 2. And now we have 2 times 2, we can erase this and we can put 4. We have 4 hydrogen little atoms. So that is the basis. We're going to do 1 or 2 more practice on your paper, so we'll do those together so you guys can kind of see and make sure that you're following along with me. So let's go ahead and get to the next one. All right, so now we got another equation here. Let's see. Let's go ahead and go through our steps. First, we got to go through and see what element is on each side. So we got carbon on the left, we got carbon on the right. We got hydrogen on the left, and we got hydrogen on the right. Boom. All right, so now let's count them up. We got 1 carbon over here, we got 1 carbon there. So far, so good. Now, what about hydrogen? We have 2 hydrogens over here, and we have 4 over here. So this is an easier one, right? Because now we found which one is going to be in balance. That's going to be our hydrogen here. So we got to change this guy right here, because this is the minimum number of hydrogens that we can have. So let's just add a 2 in front of hydrogen. So when we do that, you are going to get 4 on this side, because remember, we multiply here. 2 times 2, you get 4, and bada boom, bada bing, we are good. That is a balanced equation. Okay, cool. That's an easier one. Let's do a little bit of a trickier one. All right, here's one for you life science / biology people. This is one that is an equation that you will need to know in life science and biology next year when you take it. But it is going to be the recipe or the equation for photosynthesis, because you're taking carbon dioxide from the air and water, and you're making sugar or glucose and oxygen out of it. It's what allows us to breathe. It's all good. So let's go through our steps. So first of all, we need to balance this. So carbon, we got hydrogen, we have oxygen. Basically. We got the same thing on the other side. So let's count them up. We got 1 carbon over here. We have 6 carbons over here. On the left side, we have 2 hydrogens, and then on the right side, we have 12 of them. Over here, as far as oxygen goes, we have 1, 2 with the carbon dioxide, and we got 1 with hydrogen, with water. So that's going to be 3 oxygens. And then on this side, we have 6 with the sugar molecule, and then we have 2 with our oxygen molecule. So you add those together, and you have 8. So now we need to figure out how in the world we start balancing. Every single one of these is going to be off. So let's start with the smaller molecules first, because we don't want to add more glucose. We don't want to add more numbers where we don't have to. We want the simplest balanced equation that we can get. So let's start with carbon. We know that we have to get this number up to 6, and the only source of carbon in the reactants is going to be the carbon dioxide. So I'm going to add a 6 here, and that's going to change this number to a 6. But it's also going to change our oxygen number. So I'm going to keep a tally as we go along. So 6 times 2, so 6 times 2 is 12, plus 1 more, you have 13. Okay, cool. Now let's look at another one, hydrogen. Hydrogen also might be an easier fix because we have 12 here, 2 there. That is the only place that we can get any hydrogen on the left side of our equation. So let's go ahead and make that a 6, because 6 times 2 equal to 12. Bam. Yay, math. All right, so you get something like this, and then you add in 1, 2, like so. And keep in mind what's also going to change, our oxygen again. Booyah, there we go. So 6 times 2 is 12, 6 times 1, because we're just assuming the 1 there. So we're adding 12 plus 6, that's going to be 18 oxygen. Okay, so now we have our carbon balanced, we got our hydrogen balanced, we need to fix the oxygen. So let's move over to the product side and see how we can do that. On the product side, we have molecules, O2, and we need 10 more, we need 10 more. So what is the easiest way to do that? The easiest way to do that is to add a number in front of oxygen. So when you do that, you end up with, let's go with, some of you guys might be thinking, well, you need 10 more, so you put 5. But notice if I do that, 5 times 2 is 10, but I still have this and I'm adding 16. So I still need that to be 18. So instead, I'm going to add a number 6 that goes right there. So 6 times 2 is 12, plus 6 is going to be 18. And now we have our oxygen balanced. Yay! All right, so that is balancing equations in a nutshell. We're going to be focusing on this week. It's an important skill. It's important to be able to do this. It does take some practice for some people, especially if you don't get it like right away. But over time and with practice, it becomes a little bit easier. So we'll do this week. We'll continue talking about chemistry and all that good stuff. And the video next week, I'm hoping I'll have kind of like a lab type thing, kind of like I did last time, so you guys can see things in action. Until then, stay safe. I appreciate hearing from you. And if you have any comments, questions, or concerns, please feel free to email me. All right, guys, have a great week. Bye.